In the last module, we took a look at displacement as the difference between two position vectors. So in this module, I want to compare and contrast the idea of distance versus displacement, which tends to be confusing for many people. Before we talk about displacement and distance, though, I want to set the terms for what we're discussing. So assume 2 points in time. And this is the sort of thing that isn't often discussed explicitly, that there's a context in which we are working with these terms, and you have to have that context clear in your mind. So we have 2 points in time. We'll have some initial time, which I'll call t sub I, and some final time, t sub f. So these are two specific points. Now if I have a particle, then I can define where it is at those 2 points in time. I might have some initial vector that describes where it is at the initial time, and then a final vector, r sub f, that describes its position at the final time. Positions at t sub I and t sub f. Okay, so given that we're talking about 2 points in time and two specific positions at 2 points in time, we can define now what we mean by a distance to be the total length covered by a particle going between those two positions. So the distance is the total length covered by the particle. The displacement is simply the difference between the two position vectors. And as like before, we represented displacement as delta r, as the difference between these two vectors. So while distance is the total length covered or the total length traveled by the particle, the distance is a scalar. And the displacement, that is the difference between two vectors, it is also a vector. So that's the first clear distinction between a distance and a displacement. A distance is a scalar, while a displacement is a vector. So just as a very simple example, imagine that we have some particle. It traveled 4 meters to the east, say, or 4 miles to the east, and then 3 miles south. And so the time at which it was here at this initial point would be t sub I, and then at some time later it's at this final point t sub f. And so the distance is simply the total length traveled. And so it traveled 4 miles and then 3 miles, and so the total length traveled was 7 miles. The displacement now is a difference between two vectors. So let's first, if we want, we can set up a coordinate system here, and we can be anywhere. So I'm going to set it down here just to get it out of the way. And so I can have a initial vector is the initial position at t initial, r sub initial. And then the final vector is in the position of the particle at the final time. And so then the displacement, delta r, is just the final vector minus the initial vector. And if we do that here graphically, The displacement vector is a vector that points from the initial position of the particle to the final position of the particle. And so in this case, if this is 4 miles east and 3 miles south, then the final displacement would have a magnitude of 5 miles, and it will point 36.87 degrees south of east. So again, for the distance, we have a scalar 7 miles, and the displacement now is a vector 5 miles, and it's pointing at this 37 degrees south of east. So the vectors, position vectors themselves, are of course dependent on the coordinate system, but the displacement vector is not. For example, if we had a different coordinate system, we could, let's say, make a coordinate system up here, and that would give us different, given this new coordinate system, we would have different position vectors. There's R1, there's R2, R initial, I should say, and R final. But the displacement vector, the difference between those two vectors, is the same as the difference between our original yellow vectors. The displacement vector is independent of the coordinate system, and in terms of the displacement, it points from it's a vector that points from the initial position to the final position. Okay, let's look at a couple other examples here. And if I give myself here a coordinate system, and now I'll call this just plus x and plus y. Imagine that I had a person I represent as a particle that moves 7 meters in this direction, 7 meters, and then 5 meters in this direction, and then 3 meters back, so it ends exactly where it starts. So what is the difference between distance and displacement? The distance now is the total length traveled. Well, first traveled 7 meters, and then 5 meters, and then 3 meters, for a total of 15 meters. Now the displacement, if we look at the position vectors, we see that the initial position vector and the final position vector are exactly the same. It ended exactly where it started. Well, then the difference between two vectors that are exactly the same is 0. So the displacement in this case is 0 if the particle ends where it started. And so you can see there's quite a bit difference between the distance and the displacement. As always, the distance is a scalar and the displacement is a vector. And you can have a substantial distance covered with the displacement being 0 if you end up at the same place where you began. Okay, so let's do look at another example. Let's say I have a particle that simply moves one direction in a straight line. And so this particle moved 9 meters. Let's give ourselves a coordinate system. It moves 9 meters in the positive x and the positive y. So is the distance and the displacement the same in this case? Well, the distance here is 9 meters. That's what it travels. Is the displacement also 9 meters? And the answer is technically no. The magnitude of the displacement is 9 meters, but the distance and the displacement can never be exactly the same because a distance is a scalar and a displacement is a vector. The displacement, if I were to write it exactly, delta r is 9 meters I hat. It is 9 meters that points in the positive x direction. And so while the magnitude of the displacement is equal to 9 meters, which is equal to the distance, the displacement itself is a vector. And so that leads us to an important point, which is the magnitude of the displacement is always equal to or less than the distance for a particle that moves between 2 points in a certain period of time. So, for example, now, if we have a particle that moves 3 meters and then 2 meters in a straight line, the distance, which I'll just call d now, is 5 meters. The displacement r is it's a magnitude 5 meters in a direction. We'll call I hat if we let this be our positive x direction, so it's a vector. But if that 2 meters were in any other direction, say for example 3 meters, then any other direction that's slightly different than along the same line, then the magnitude of the displacement will be slightly less. The magnitude of the displacement will be less than 5 meters. So for a particle moving between 2 points, the magnitude of the displacement, the maximum value it can have is the distance. The magnitude will always be equal to or less than the displacement of the particle. And that's the end of this module.